So I'll just do a quick example, only a few more slides left. I know this is quite a long video. Don't try this on holiday, of course, but I'm sure it does happen. A group of student doctors go on holiday. For a clinical trial, they decide to climb up a tree and swing from a rope attached to a pole. They're near a cliff edge, and if they time it right, they can let go and fall into the sea without hitting the cliff. And what we want to know is what's the minimum angle that it's safe to let go of the rope without hitting the cliff. So we've sort of drawn this here. The safest horizontal distance from the pole to the edge of the cliff, I know this is clipped off a little bit on the screen, the safest distance is 8 meters here. And if we choose this angle here to be our angle, that's when we can, once we've chosen our point of reference, we can then label all the sides of our triangle. So they climb up this tree, they swing, and then they let go at least here at the earliest. And we want to know what's this minimum angle that they can let go of the rope. So let's zoom in on the triangle and draw it out a bit better. So choose the angle first. You have to choose the angle, otherwise you don't know which side is the adjacent and which is the opposite. So we're going to choose this angle here to be alpha. And I suppose really you have to look at this triangle with your head tilted to the left now, because the side that's opposite this angle is this one. So this is opposite. So this is therefore the pole is the adjacent, and the longest side is the rope, is the hypotenuse. So the hypotenuse is 10 meters because the rope is 10 meters long. The distance from the pole to the edge of the cliff is 8 meters. So we know the hypotenuse and we know the opposite. So which trig function do we use? Cos has the hypotenuse, but it doesn't have the opposite. Tan has the opposite, but it doesn't have the hypotenuse. So the only function that has the two sides that we care about is sine. So we're going to use the sine function. So the sine of this angle is going to be equal to the opposite length divided by the hypotenuse length. So the sine of this angle is equal to 8 meters divided by 10 meters. So the sine of alpha, opposite over hypotenuse, which is equal to 8 meters over 10 meters. So the sine of the angle is actually the sine of 8 over 10. And 8 divided by 10 is 0.8. So the sine of our angle, which is our angle sort of written in another language if you like, is equal to 0.8. So what we need to do to find an angle, what we sort of harp on about, is do the inverse trig function. So we do shift sine of 0.8. Sometimes you see it written as sine to the minus 1. And the angle is therefore 53.1 degrees. All helped by our calculator, of course. Here's just one more quick example. We've got a truss holding up a lighting rig, and the instructions state that the maximum strength of this red truss here comes from when there's an angle of 45 degrees. So obviously you need to set things up the way they're meant to be set up. But the only truss available is 3 meters long. So we know this red line here is 3 meters long, and we know the angle here has to be 45 degrees because the instructions tell us. We need to figure out how far apart to bolt our two blue support trusses, if you like. So we need to know this gap here. And if we start to label our triangle, if this is the angle, then this side here is opposite the angle, and this side here is adjacent to the angle. And we don't want to know how high this is. What we have been asked to find out is how far apart should we bolt these two vertical supports, which means how far is this gap here. So let's work it out. Basically, going back to this triangle, we know the hypotenuse and we want to find out the adjacent. And the only trig function that's with respect to hypotenuse and adjacent is the cos one. Well, the only main one anyway. So we're going to use the cos function. So the cos of the 45-degree angle is equal to the adjacent length, which we want to find out, divided by the hypotenuse length, which we know. So the adjacent length is the gap, and the hypotenuse length is the length of the truss. I'll just refresh your memory. So the cos of 45 equals this length, the adjacent, divided by 3 meters, the hypotenuse. So what we do is rearrange so that the adjacent is equal to the hypotenuse times the cos of 45. We put 45 in our calculator, press cos, and then it'll tell us that the gap is the hypotenuse times 0.707, which is the cos of 45 in degrees, of course. So the length between the two vertical supports is 2.12 meters. So now we know exactly how far apart to put these vertical supports. If this is 3 meters, this is 2.12 meters. So basically, guys, thanks for listening. I know it's been a bit of a whistle-stop tour of trigonometry, but you have to start somewhere, and hopefully you'll go back over the video, and any questions, just leave a comment. Alright, thanks for listening. Thank you, bye.